Good morning, everyone. Uh, Welcome to our workshop of DestinE in ethical AI in the weather domain. First, before we start, I would like to discuss some housekeeping rules. For everyone joining online, please note that your chat is not enabled, but you can ask all your questions through the Q&A function. You can find it at the bottom of the bar, and we will address them later on. For everyone offline, please note that the audio is on, so please be considering that. Then a quick agenda view. We will cover some numerous topics, and then in the middle at 10:30 we will have a break. And first we will start with an introduction of Stefan.
Yes, good morning also from me. My name is Stefan Siemen. I'm from ECMWF. I'm the Strategic Projects Coordinator at ECMWF. And over the last year, I was looking after the work related to AI ethics, which we did within Destination Earth. So what we try to do in the next 3 hours is to present a bit the work we've done. There's a lot more to do, and also show which direction we need to look at. And so I will start a little bit with an introduction and setting the scene a little bit before we go into any more details of the study. Quick word to ECMWF. We're an intergovernmental organization established in 1975. You will have perhaps noticed our 50-year anniversary over the last year. We're split over 3 sites. Today we're broadcasting from Bonn, which is one of our newest sites. But we're also in Reading with our headquarters and our supercomputer in Bologna. We're running a 24/7 weather service with forecasting in the medium range, seasonal, distributing the products around the world in real time for research, industry, and government agencies. We also have a strong research institute within developing the model, looking at new things like AI. So there's a strong link with research. But just to show on the right side, we also have very strong links to the European Union. We're supporting the Copernicus program with hosting 2 of the services, climate change and the atmospheric monitoring one, and also strongly supporting the emergency management services. We also recently started to support the Global Gateway from the European Commission with Space for Early Warning in Africa, SEVA, which is also a lot of activities making forecast data available across that continent. But the focus, of course, today is, last but not least, is on Destination Earth. That is a groundbreaking initiative by the European Commission to support new developments of capabilities in developing digital twins driven by strong weather and climate global models within these engines. And what ECMWF supports in that is not just the digital twins itself, which are based on physical models, but also the digital twin engine, which is coordinating this work with the whole work stream from receiving data and giving products out. And more about that a bit later. So why we're here is that over the last years, we have seen a rapid increase in AI use in weather forecasting. And it seems now a long, long time ago when ECMWF started in 2018, looking at concept of how to use AI in weather forecasting. And the world has changed very much since then. We saw based on all the work which happened in other domains on generative AI, we saw the first forecast models appearing in 2022. I'm not going through details because these things, of course, are also changing all the time. But we saw constantly improvements driven mainly by large IT companies who had the compute power to work on these large AI models. But we have not rested with our concept in 2018. We have really reviewed it. We have really worked on it. And starting in 2023, we were able to have first prototypes of our AI-based weather forecasting system, AIFS. And that development has continued and ended in last year with the first operational releases of the AIFS single, so the single forecast on the ensemble in July last year. And that, of course, is now the start of operational use of AI in forecasting. So, of course, the question is, how can we do this the right way and most ethical. The impact of AI models has been great. This is just, I don't go into the details, but this is one of the growth charts we use at ECMWF to show how our forecast has improved since the 80s. And you can see that now that all until the recently is the physics-based, and you can see the jump the AI-based forecast models have brought on all time ranges, the 3, 5 days and 7 days. And you might say, okay, this is nice statistics, but what does it really mean for extreme weather events? And just one example of a recent tropical cyclone, that it was possible to give a 12-hour earlier warning of that event thanks to AI. And you will see there's quite a lot of good results and what we can see from that. And again, we're not talking here about that, but have a look at the IFS blog, for example, at ECMWF, and you will be able to see more of the success stories of using AI. But AI gave us also another chance to work with the community, because we realized very quickly that the race for AI, providing AI-based weather forecasting models, we all have in the community facing the same challenges: getting the data, how to do the training, setting up the models, managing them, how to organize the graphs within the models, but also how then to do the inference. And it was a great come together for the community. That's something we started at ECMWF, but has now been picked up by the wider meteorological community across the globe, now contributing to a framework so that we can build on all these components and have the same framework underlying, which helps us to be faster in developing, because we can really concentrate on the key aspects of training our models, and all the technical challenges around it, we work together to solve them. So all this now leads me now to Destination Earth. Destination Earth, as I mentioned, is a big initiative of the European Commission to go from the traditional forecasting model to digital twins, and it's really to bring forecast data faster to the impact side and have the models within the twins much closer and much easier to be used by users, and get the user requirements through co-design faster into the developing processes. So when Destination Earth started 4 years ago, the digital twins themselves are physics-based. Luckily, AI was already on the map, and we had already planned to use it, but now, of course, it becomes more and more of an important role. So ECMWF, as I mentioned already earlier, so ECMWF looks after the digital twins themselves, the extreme weather one and the climate change one. So the 2 timescales we doing global forecasting on. And I mentioned already the framework, the digital twin engine, which allows us to make use of the power of the Euro-HPC supercomputers the Commission has, and could provide us for this project. And since we have various different machines, we needed to have, normally these forecast models are tuned for specific machines. Here, what we could do is build a framework, makes it very easy to switch between the different HPC sites, thanks to the digital twin engine. So that is that. But of course, as I said, we want to also get closer to the user. So there's 2 other big parts we're not talking today about, which are part of Destination Earth. It's a data lake. It's about how the data physically then also gets exchanged between the different HPC sites to different user areas. A cloud, that is a data lake which EUMETSAT, our sister organization on meteorological satellites, is overlooking and working on. And then we have the European Space Agency, who works on the core platform, which allows users to run their use cases and their applications on DestinE. So if you want to know more about these things, as I said, we're not covering that. Please go to the Destination Earth webpage and you will find more information about that. And of course, DestinE, because it's really pushing the boundaries, and we can make use of these fantastic Euro-HPC supercomputers, it made sense that all the things we anyway have in the community, like this Anemoy machine learning framework, that we then also integrating it with the framework we use for DestinE, the digital twin engine. And it has been now a very good collaboration to bring this in helping also to test it in earnest on different supercomputers, different environments, integrating the workflows with DestinE. So, and we have really very good speed up in scalability thanks to the continuous testing on the different supercomputers, latest technologies and hardware. If it's a Monastro, Lumi, Leonardo, Meluxina, and now also we're using Jupiter, the new exascale supercomputer in Germany, part of EuroHPC. So this is really vital, and that gave the original hyperscaler such a boost for them to do AI was that they had the compute power. And now EuroHPC and DestinE gives us also that to look at the larger scale and speed up our developments. So the aim at Destination Earth is not just the atmosphere. I mentioned now IFS, by the way, is our physical model. AFS, surprise, surprise, is our AI-based model. So these are atmospheric models, but they're only the start because there's also a lot of activities going on building AI-based models, oceans, sea ice, waves, hydrology, land, and that will then really combine also and give us more power when we talk about the digital twin concept we want to achieve in Destination Earth on a global modeling platform, which allows us to run what-if scenarios for the future and better preparation. So, but it's not just about getting better forecast. AI is also changing the way we're working. And we're really exploring a lot of different ways to enhance interactivity, the usability using AI. And I think one of the more interesting and we get a lot of attention concept is a forecast in a box. So we can take a trained model, forecasting model, and with relatively modest hardware, you can run your own weather forecast. And we do that through a framework in which we prepare initial condition. The model can be then run on your local device, but we also have the scripts ready for creating user products, for visualization. And all this can be packaged up and provided to users. So users don't have to just take numbers statically as a forecast. No, they could actually take that. And of course, the next step is if they can run something locally, is they can also then, of course, adapt it and change it. And of course, this is just also one example which shows you that whatever we have put in place to control quality, assuring quality, working with user that everything is ethical set up is challenged because this is a totally different way how we then talk to users and what users are doing with our data. Another example of how AI is changing the way we're working is the chatbot. I think everybody is now doing chatbots, combining the power of large language models with the large amount of data we have. So we have parallel to this, a work item going on, linking a chatbot trained with the digital twin engine I mentioned, so the framework, which controls how the twins are run, data coming in, the data being disseminated, and also knowing what's going on, where is which data set. As I said, DestinE is quite a distributed setup. A lot of things are happening, which data set is available at which part. So this all is, the chatbot can answer and can work with, thanks to having this connection directly to the digital twin engine. So this is another way of going beyond in future, not just giving documentation out, but also that user interactively find out information. And of course, in real time, because it can query what's happening on the system. So now focusing much more now on the ethics. Of course, DestinE, as a flagship initiative of the EU, it's vital that we're also demonstrating that we are really aligned with European values, with regulations. And when it comes to the AI, you will have seen there has been quite a public discussions about the right usage of AI and the dangers of it, possibly using it. So it's very important that we make sure that we are delivering on this and showing that users can trust and can also say that the whole setup is fair and open to everybody in the same way. So what we're wanting to do in DestinE from the beginning is demonstrate also good practices, encourage discussions and uptake. And that was really a key point of this project. But also build trust with downstream users, because we know from experience from the past that if user trust you, if user believe in your data, and then they know it brings value to them, then they also invest into taking it up and work with you. So we really working hard on that and to see how we can help on this. And as I said perhaps already, we want to differentiate also a little bit. There is plenty of AI models now happening. There's a lot of developments, but users are starting more and more to ask, yeah, but which one should I trust? Because having 20, 30 forecasts, possibly interactive, it's hard for users to choose. So they need to know where they can put their effort and where they can put their trust. As a meteorological community, we actually have a lot to build on, because weather and climate forecast had always a challenge that it was questions about the quality of the forecast. And it was always a big part of the work, how to build trust, how to give meaningful and impactful forecast and let users use it. So this is not new for the community, but as you have seen from what I mentioned about the application, the way of working is changing. It's not just the quality of the forecast, but it's also the way we're interacting, and we need to make sure that we have build the same trust as we have with our physical-based models. So first thing, of course, is that we have been always open about forecast performances. Centers like ECMWF or National Weather Services providing information about their quality. There's a global exchange of forecast verification results. So that is very important to also allow research to improve forecasts. And then, of course, we have a lot of trust built through a long series of successful but also unsuccessful forecasts of extreme events. So it still happens, and it will still happen, that we cannot forecast everything in the right way. But we learn from these mistakes, and we're improving, and the public can build over long-term a trust that, and also the agencies who have to use our forecast can build and trust that we are working with this, and also learn from these unsuccessful forecasts to improve our work. And I think what this community also has shown is that with all the advances in weather forecasting technology we had in the last 30, 40 years, the human oversight has still developed and adapted to it. It's still there, but it's not anymore manual forecasting, manual observation stations everywhere. We have adapted to it, but we have kept the manual, the human oversight, and this is something very important when it comes to the ethical fulfillment for the future. So, I mean, first of all, you might ask, so what are you defining now in ethicals? And if you look at there has been a nice ethics guidelines back in 2019, of course, which now sounds quite old, but still actually it still has quite a lot of good basis regarding the fundamentals of ethics for the EU. And as I mentioned just now, the human agency and oversight is a very important part of this, that we still have to be in control. We still have to have the ability for humans to intervene and to assess the quality and also the actions taken out of these forecasts. Technical robustness and safety. These forecast system needs to be resilient, reliable, robust, secure. You will see that has been a theme of some of our work, and that is very important, of course, anyway, for a forecast system which has to be delivered daily. Privacy in data governance. It's something which sometimes in our community, because we don't have very much personal information, is a bit overlooked, but still very important to have this, especially the data governance, to make sure we know the data used, how it was provided, and the source of them. Excuse me. Transparency and explainability. So that's the openness to show that. Sorry. No, the transparency and explainability is, as I said, we have always been open about how our systems perform. what data they use, and that we have to continue, and it's very important for AI. And diversity, non-discrimination, fairness, I mentioned already, we have to make sure that we're not starting to get biased by using AI. And it's all, as I said, we're getting more and more AI-based solutions, and we're getting a lot of good results. Everybody's claiming, of course, they have the best. But now the question and the challenges for decision makers, how do we get the right advice and what we can trust for these forecasts and how we use AI? So we need to build this trust and believe, make users also believe that this is really the right decisions they're making, and it's all on a sound basis. So this whole ethics is not another hurdle put in by, by some lawmakers, but it's really also helps us thinking about ethics helps us also to bring our work faster to users, because they will faster adapt it because they can trust it and they believe in that they're using the right solution. So one key legal text, which is very important in Europe now for ethical use of AI, is the EU AI Act, coming out in August 2024. It's still quite young as a legislation, and you see also there's still movement of adapting it to the changing landscape. So please have also a look. If you look at the EU Act, please look also in November 2025. The Commission published what they call the Digital Omnibus. So it's already thinking about the next step, how to move forward out of the regulation, how to the compromise about not slowing down technical scientific developments, but still making sure that we keep the foundations. You might know the EU AI Act has a risk-based approach, so it asks every user and organization to evaluate their use of AI and the models on a risk scale. It's so there's 4 levels: unacceptable risk, which means simply you should not use it. There's high risk, which means you have a lot of conditions under which you should report and also be open about the usage of that. And this is also where the regulation has most condition about. But most will fall under the limited risk or the non-risk, which is actually that there's still openness requirement and some governance to be done, but it's much more open. And I think the theme is to wait more to allow users to really access from the risks assessment, make that decision how much they need to adapt and provide with that. So the AI Act requires, in a sense, an inventory of what AI use you have, a risk assessment, of course, because you need to see yourself in the risk level. It's a lot about AI literacy and human oversight, as we already discussed. AI literacy is really making your users and your developers really aware of the impact using AI, and that they know the implication, and also it's open and visible to everybody involved and any stakeholders. So in a sense, what it requires is an AI governance you need to have in your organization, looking after these aspects and coordinates them. But of course, these regulations should not be seen in isolation. There's a lot of other EU regulations like the GDPR who relate to it and should, of course, be followed. So from a practical level, for example, at ECMWF, we see a lot of setups you would do, for example, for cybersecurity, linking already also into this one regarding reporting and keeping assessment of what software you use, which packages, for example. So there's a lot of things we do already, and it fits actually in to also integrate that with what you do for these kind of provisions of the AI Act. So it's important to see what you already do. And also it's important to say the Commission not just has the AI Act. The AI Act is actually accompanied by large-scale investment. You will have heard about AI factories, gigafactories. So there's a lot of money also going in, because as we said earlier, hyperscalers and our companies had advantages because they had the technical infrastructure to do. So we know that in Europe, to advance, we also need these kind of infrastructure. So there's a lot to be said also for this investment helping Europe, and that should be also used by us to go. Perhaps one thing I should say about the risk-based approach, it's unfortunately not that easy sometimes because, for example, weather forecasting on its own might be seen always as a non-high risk. But of course, especially when you talk about Destination Earth, where we want to link user application with the digital twins, the forecasting models, you can very quickly build a chain or use case where you are actually getting into the more higher risk area. Even so, the weather forecast part or the climate change part, climate forecast part is not actually the high risk part. So you need to think also about the downstream application, and you need to be prepared that downstream application will have obligations from the AI Act, which then reflect up to the upstream forecasting models, which need to provide information and openness to provide openness for the high risk application. So as part of that, to explore all this, we started back in October 2024 this current contract, which we're now reporting today about. And we're coming nearly to the end of this first contract to look at how we can provide the basis to look at the ethicals and how we can possibly provide the framework to help our users, developers, to provide this necessary level of services. So what we did within the project is, you will see it in the following presentation, we have looked at specific issues around the ethical use of AI. We have a series of white papers, and also these will be shared with you after the meeting. So we would like to have some feedback, but it's good that you have first a presentation to give you an overview. And there's clearly communication challenges we can see going ahead. Then we also build, and that you will see after the coffee break, some guidances and best practices for AI developers. For us, very important to start building something which we can give, because developers are not always in-house. I forgot to mention that with DestinE, we have now well over 100 industry partners and organizations helping us developing the system. So it's very important that we have something to maybe to give to them, but Sebastian will talk after the coffee break about that. And then, as I mentioned already, how can we build trust and confidence, how we can inform, forecast and the uncertainties, differentiate between public offering and also about non-European entities offer. So what we said before, we're trying to explore with this contract. So framework, there was a high a high target for us to start with. We're not there yet because we have bits and pieces, but we see there's a lot of more work to be done. We definitely have started good discussions, good feedback on this really vast topic, which is also quite complex in parts. And what we find also, it needs to be really embedded in the processes, and needs to be adapted also to the needs, because a one-fits-all framework can also be an overkill for small new developments and might not cover complex needs for operational systems. So it's something we are very aware about, that there might be some variance in what we can provide. We see a huge importance in the support of AI literacy for developers and users. Again, this is it's anyway something which we should do. But it's also very important when it comes down to downstream users implementing possibly high risk applications with AI-based weather forecasting or climate change models, that they can also rely and also build on this AI literacy which we are providing for them. So as I said, very important to build these guidance and white papers, and we're very keen also to share them with you after the meeting. But it's really only the start. This should not be seen as, oh, that's it, that has been done. there's a lot more work to be done, and we talk after that, after the break, a bit more. Sorry for losing my voice, but it's also the good time to switch. Uh, mm. I think, Jordi, are you ready?
Yes, I just had to unmute myself.
Yes.
Yeah.
I know, but then, yes, I would want to say Jordi is one of the first contractor who talk now from Atos and present some of the results. So, Jordi, please take over.
So I'm just so it says I'm controlling, but now it's switched. Okay. Yes. So thank you for the introduction, Stefan. I think it was a great introduction to why ethics matters, the reason for it, and it's a good opening topic or a good introduction to the first white paper that we've written on the adoption of ethical principles in the meteorological domain, which was the opening white paper for a series of white papers on these topics. And today I'm going to talk mainly about the ethical concerns that come with using machine learning based forecasts. Of course, the same concerns or similar concerns also arise for traditional numerical weather forecasting. But there are some differences, and also it is clear that how strongly these concerns apply or how important they are depends to a large extent on how we are actually using machine learning. And for that, I wanted to once again show a short or small diagram on the use of predictions and machine learning in DestinE and the AI-related activities there, because as Stefan already mentioned, the current data flow is still through a traditional NWP model. So we go from observations, we have data assimilation, the analysis, and then we have a traditional physics-based model. We get predictions, and then in the end, there are downstream systems, and the users consume the data, the information. There have also been experiments with chatbots, as Stefan already mentioned. So that's the use of AI. But there are also small parametric parts sometimes integrated into physics-based models. So that's the smallest, as you could say, the smallest variant of using machine learning. Then the next step, and that is what's been happening for the last, let's say, 4 years. And there has been great progress in the data-driven forecasting models that are based on the analysis. And there, of course, all these concerns already become very important. But where it becomes even more strongly important to review these concerns is if we have an end-to-end model that goes directly from observations to predictions. And there has already been research also spearheaded by ECMWF on direct observation prediction models. And there we don't really have this correcting factor of a physics-based data assimilation that platform or system. And now I'm checking if I can actually switch the slides. I think it works now. So what ethical challenges did we think about? And in the end, I'm also giving some examples how they're actually materializing in concrete downstream use cases. Then I'm also going to highlight some approaches how to build trust and overcome these challenges. And of course, as I already stated, these ethical challenges, they also arise for numerical weather predictions. But here we have some twists because the models themselves are a bit different. So one huge part, and that has always been a problem also in the history of weather forecasts, is we have scarce data. And an uneven distribution of weather monitoring networks. And this may, of course, then in turn affect the accuracy and fairness also of these predictions. We know that the weather monitoring networks are really well developed, for example, in Europe, in parts of North America, but in the global south, for example, in Africa, we have a less dense network. So this might lead to less accurate forecasts, and this might then also affect marginalized communities there. And this also is the same for, it's similar for physics-based forecasts, but there we have this correcting factor of, the physical laws, they are the same everywhere, and we also guaranteed that the predictions at least have to adhere to these physical laws because it's baked in the model. Another problem for the new models is that we have certain mistrust of AI models in the wider public. This is in part because it's just a new technology, and it takes time to build trust in these models. Whereas for the physics-based models, there has been a history of 40, 50 years where this trust could be established. And also, it's exacerbated by the fact that these new models are very complex and opaque, and they lack interpretability. So it's really difficult to understand their decision making or their predictions. And this comes with concerns about how transparent and how accountable decision making based on these models can be. And of course, as I said, physics-based forecasting had to deal with these problems as well. But there's an implicit trust in physics-based models to some extent, because we know that the natural laws have been built into it. The algorithmic bias of machine learning models is also a concern, in particular because they are best at predicting data that they've already seen, so states of the world or of the weather that they've already seen, and it is still an area of active research how well they will work for a world where the climate has changed, how well they can predict new extreme events. And this still requires more research to be able to fully trust in that and overcome biases. One thing that distinguishes ML-based models from physics-based models is that the cost of training these models is very high in electricity, in technology, but also in acquiring the expertise to train these models. And that's a very it's a huge hurdle for smaller entities to then actually develop those models themselves. And it limits the circle of entities that can train new models, which then in turn comes with the concern that it might actually concentrate power with a small number of private entities. On the other hand, the inference for ML-based models is much cheaper than it is for physics-based models, and it's much quicker. So it's a lot easier to run forecasts, also for small entities, which can lead to a multitude of forecasts, all of varying qualities, and it becomes difficult to actually choose which would be the best one, which forecast to trust. And this can be a challenge to this concept of one voice, looking at the national mandate of the states to actually provide weather warnings to the public. And it's also, if you think about these ethical challenges, they are not in isolation, but usually they interact with each other. And then thinking about what entities actually have the resources to train AI models, and looking at this timeline of models that have been trained, there are lots of non-European hyperscalers that have been training these models. And you can, of course, think about conflicts of interest that could arise there, and that could then also lead to different weather warnings than we would normally expect. What implications do these actually have, and how do these concerns materialize in actual downstream use cases? For example, well, to give one example, machine learning models have been used to forecast urban heat stress. But in this use case, if you have sparse sensors and an algorithmic bias, for example, that makes a difference for informal settlements or sparsely populated settlements, that can lead to a misestimation of risks. And then, in turn, if decisions are based on that, it could lead to worse health impacts in these areas. But also the opacity of the models then makes it difficult to actually challenge the decisions, which in turn leads to a reduction, or can lead, because this is hypothetical, can lead to a reduction in public trust. Because we are actually looking at forecasts at a neighborhood level or street level, if we then also incorporate mobility or location data for the forecasting, this can in turn lead also to privacy risks, which is quite uncommon, as Stefan already stated, for weather forecasting. Okay. In a similar vein, for flood forecasts, if we use biased training data, for example, that underrepresents rural areas, that can lead to weaker warnings and a higher residual risk. And also here we again deal with model opacity. It's just difficult to assign responsibility if we had an automated decision-making process, and that would lead to poor decisions. Also, if we would have concentrated or advanced forecasts concentrated in the hand of certain private parties, that could lead to unequal access and then poorer protection for low-income regions. But looking at the long term, if we have climate scenarios that we could use for renewable energy investments, for example, into wind farms or solar parks, if we there have unequal data, then that could lead to unequal investment opportunities for certain areas. The high training costs could lead to power asymmetries because, again, we have if we have powerful entities with large resources, and these could have better predictions and could then make better informed investment decisions. And we also really have similar concerns here for the long-term scenarios. So how do we overcome these challenges for trust and ethics? And I'm focusing here mainly on organizational and communicational ways. The open sharing of methods and data and results that has already been practiced by ECMWF through their publications and the AIFS blog increases the transparency of those of the models, of the ML-based models. And it also improves robustness because it's easier to review the results, the data. It's easier to spot errors and problems with fairness. In a similar vein, the outreach and education activities of the ECMWF improve the AI literacy of the community in the same way that also the sharing of the methods does. And the community and collaboration efforts, for example, through open source platforms and frameworks. A really good example is Anemoy, that also fosters the adoption of those models, and it reduces the complexity of actually developing the models to such an extent that it becomes easier for smaller entities to also participate in the development. The open competitive challenges, two examples are Code for Earth and the AI Weather Quest, also bring together the community, but they also serve as a validation point under standardized conditions, so that new models and new approaches can be quickly but thoroughly validated and lead to innovation. A huge impact that the Euro HPC can make is by making computing resources accessible and thereby reducing this effect of the huge training costs. And then in the end, to build general trustworthiness frameworks that actually operationalize these requirements that are posed by the EU AI Act, and to turn them into practical guidelines is a large topic that Sebastian will talk about after the coffee break. But then there are also technical ways to address these concerns, and that is a huge topic in itself. But we look closer at two selected areas. One is robustness and reproducibility, which Sebastian will talk about now. And then we also have this topic of explainability and vulnerability to adversarial manipulations that Ranjit will later talk about. Thank you.
Yeah, thank you, George. With that, I will come to the second white paper of this white paper series on robustness and reproducibility in data-driven weather forecasting. As George already mentioned, one can take two different views on this trustworthiness topic. On the one hand, we have processes that are required for trustworthiness, communication, and so on. And on the other hand, we have purely technical properties of the AI system itself. And that is something that we have been focusing on particularly in this white paper, which is a very technical white paper, especially compared to the first white paper. We still, it should still be readable also for non-experts, but it is considerably more technical than the first white paper, definitely. Let's start with a bit of motivation. We've seen in the first talk that data-driven models are increasingly being used, being operational, and used to complement physics-based predictions. And this, of course, introduces new challenges and new ethical challenges, in particular also to robustness and reproducibility. If we're looking at what has changed from physics-based forecasting to AI-based forecasting, I think the main points that we can focus on is, on the one hand, the opaqueness of the models. So mainly the data-driven weather forecasting models are black box models, and in combination with the, at first, lack of physical grounding. So you're not sure if they will follow the laws of physics, and because they're trained on data and not on to follow the laws of physics necessarily. And this, in combination with this opaqueness, is one challenge in this realm of robustness. And the second one would be this increased stochasticity of, for example, the training process of data-driven models, which is something that can decrease reproducibility. And thirdly, also the reliance of the model performance on its training data. So for physical models, the data is obviously still important, so we need it for inference. But in data-driven forecasting, the data that the model is trained on really influences the model itself. Yeah, and that's why these are the main challenges that we looked at in this white paper on robustness and reproducibility. We took quite a broad view on robustness. So we defined robustness generally as the ability of an AI system to withstand altered condition or to maintain performance under altered condition. So typically the view that we have of robustness is we perturb the input a bit and see if the output changes. That fits into this framework, but we've expanded it a bit, this notion of robustness, and try to apply it to different scenarios. And the second topic of this white paper, which is of course very linked to robustness, is the reproducibility. And that's something that one can also view in different lights from the reproducibility of the findings. For example, when publishing scientific work, to exact bit reproducibility, which has its advantages in physics-based forecasting, but is considerably more difficult to achieve in data-driven forecasting, mainly because of this increased stochasticity. One way to measure robustness that's been used in physics-based forecasting for a long time is uncertainty quantification, which is a topic that we also laid a focus on in this white paper, distinguishing between epistemic uncertainty. So the model can't reflect reality well enough, and aleatoric uncertainty. There is an inherent randomness to what the model wants to predict. And this, in the end, comes out as uncertainty. But that's the natural variability of weather, for example. So when I said we are looking at a broad way of robustness, here you can see a short overview of the white paper. We've structured the white paper along a simplified AI life cycle. So we looked at the life cycle stages of data, then of the model development, model design and development. So the training process would fall into that, and then deployment and operation. And we've found different challenges to robustness. For example, that's something that Giorgio already mentioned in the training data. Such a challenge could be errors in representativeness, so biases in training data, sparsity of sensors in certain region. Then when we are looking at the model, we have these typical machine learning topics of over and underfitting, then questions of how do you design your uncertainty quantification, and of course, in the realm of reproducibility, this question of how do you deal with training stochasticity. And then after you have trained a model and you're deploying it and it's maybe even operational already, there are other challenges, for example, drift. So that the data that you've trained the model on has changed since you've trained the model, or trying to get your model to run on different hardware. And that's difficult because of a lot of machine learning implementations are not deterministic and depend on hardware. And that's what you can see in this graphic here. So we have the 3 lifecycle stages and the different robustness challenges in these lifecycle stages. One short notice is that, of course, one could also view adversarial robustness in this framework. That's something that we will cover in the third white paper. So we are focusing on naturally occurring different conditions and not adversarial attacks in this white paper. Now I want to quickly go through the 3 lifecycle stages from data acquisition and preparation. So we have the first lifecycle stage of data. As I mentioned, challenges can be sparsity and heterogeneity of different data sources. So you have to, of course, implement all of the different data sources in some data assimilation procedure. And this has to be robust to the sparsity of sensors, for example, in certain regions. Then we have underrepresentation of extreme events in training data. That's something that is not unique to weather forecasting, but one sees everywhere in ML. So if one thinks of in autonomous driving, there is also a huge problem that, for example, there are not enough pictures of car crashes to train on them. And of course, the behavior of a autonomous car depends on if it has seen this kind of situation in training data before. And here it's similar. Extreme events only happen so often, and that means that they will be underrepresented in the training data. And that's a challenge. On the other hand, we have seen, of course, that in some cases, the data-driven models are quite good with these extreme events. The example that Stefan showed before. But still, we need enough training data on these events in order to make it robust. Then we have uncertainty from sensor noise and errors in sensor data. So this is basically what happens if one of the sensors goes wrong and produces wrong data. And then we have also the challenge that if we don't correct these errors in the training data, then they will propagate and produce errors in the AI model itself. Now, the case is that not all of these challenges can be directly solved in the lifecycle stage of data. Sometimes there are crossings between the lifecycle stages, so there are challenges in one and mitigations in one of the others. But mitigations that we looked at here, for example, we gave an introduction to data assimilation procedures. We looked at synthetic data augmentation for these questions of bias and underrepresentation of extreme events. Of course, outlier detection and reviews. And we also took a focus on version control and documenting data sets. Then we come to the second life cycle phase, training and model building, where we have challenges like oversmoothing in certain loss functions. So when one uses certain loss functions, to train. Randomness in trainings, that means that typically these models are trained with a stochastic algorithm that may arrive at slightly different models from the same training data each time. And there may be these questions of overfitting and underfitting, or learning patterns that work for certain regions and certain time points, but where the dynamics have changed or will change in the future, where these models are not adapted to reality anymore. So mitigations that we looked at here, on the one hand, we gave an overview of uncertainty quantification methods, how to disentangle aleatoric and epistemic uncertainty, and different approaches, so ensembles and Bayesian approaches and noise injection, a lot of which we have also seen in ECMWF models. And another idea would be regularization or pre-training on broader climate data. So regularization is basically a broad set of techniques. For example, dropout would fall into that, or using penalty terms in certain loss functions. And that can help, for example, with these over-smoothing of models in training. Then we have the third life cycle stage, deployment and operation. So we have trained the model now, and we want to see what challenges can arise after we've deployed the model, or while we are deploying the model. And for reproducibility, this could be things like differences between environments, from training to deployment. So different software, hardware, and so on, which might influence the model behavior. For example, many ML frameworks are not deterministic and have some stochastic elements, or at least some hardware-dependent elements, and that's an issue to reproducibility. This is particularly relevant if one thinks about integrating these models into existing pipelines, because the hardware might be different than what the model has been trained on. And lastly, this is this topic of concept drift and data drift that I already mentioned. The quality of the models can degrade over time because either the input data changes or the real-world dynamic changes. So these are also more broad ML terms, data drift and concept drift, but are of course also very relevant here. And for good practices, we looked at aiming for some degree of reproducibility by publishing software, for example, in reproducible containers. Other reproducibility measures, such as versioning of data and model containerization, or logging seeds of certain random variables that arise in the training process, for example. And lastly, drift monitoring. And in the last chapter, we also took a process view where we looked at influences from standardization on the topic of robustness, and tried to integrate some of the best practices into this MLOps view. So how would you, so the last question that we answered in this sense is how to make sure that these topics get integrated in the processes that maybe already exist. With that, I would hand over for the third white paper to my colleague.
Thank you, Sebastian, for the talk. I think you've heard a lot about trust and AI models, but even though we have these new AI models, we have to make sure that they are being used by the users, and this calls for adoption. And one of the major factors, as you might have heard during the course of the talk, is trust in these AI systems. And the trust is not just a single factor of the AI model, but also a two-way street between the truster and the trustee, where the truster is the user who is trying to use these AI models to use these results and in critical situations. So there are different factors when it comes to the truster's trust on the AI model. It depends on factors like what is the decision that has to be made with the model. So if it's a small decision like a recommendation system, for example, so let's say a Netflix film that you are going to look into, it's not a critical decision. But whereas if you look at extreme weather events, I think this is a huge decision that has to be made by the user. So the user requires more trust in the AI model. And this trust has also been a challenge in the numerical weather prediction models, but this has been developed over time. And one of the advantages that the numerical weather prediction models had or the AI models is that they were a bit more understandable for the user in the factor that they are governed by the physical principles. And so the users were able to leverage these physical principles in turn to understand the results from the numerical weather prediction models. So one of the factors that we looked into in the course of the white paper is to see if we can make these models more understandable. And so why are these models not understandable? Is because they're mostly black box models. Not always, but mostly they are black box models that are not easily understood by humans. But we come to the challenge of these two different terms. You might have heard during the course of the talk about interpretability and explainability. And I would like to shed some light on how they differ. So a model is considered interpretable if they are easily understood by the user to understand the decision-making process of the model. Say, for example, here on the picture on the right, you see models like linear regression or a decision tree, which are easily interpretable. So as you can understand, if you have a decision tree model, which is helping you predict if you can go out today for a hike or a walk. So you have factors like, it is sunny and there's no snow if you're going in winter, and then it's a clear decision that you can follow, that the decision is an yes, so that you can go out for a hike today. So these are simple and understandable by the users. But this is not the case when you come to the latest weather prediction models. They are either deep neural networks or, in today's case, mostly graph neural networks, which are not easily understood by the user. There we have to use explainability techniques, which require additional layers to make these decision-making of the process of the models more understandable for the user. And here we have gone through the different dimensions of explainability to understand, okay, how can we make the models more understandable, or the process of the decisions of these models more understandable with some techniques that we have analyzed. So I will move on to the dimensions that we have analyzed of the AI models. So we have categorized this explainable techniques into 4 groups. So one being the scope, and the other one is the algorithm that we're using to explain, and the compatibility of the explainability technique, and at the stage where this explainability technique is used. So if we talk about the scope, it could be local or global. So are we trying to explain only a single prediction that is happening, or are we trying to explain the whole model per se? For understanding one single prediction, there are models like techniques like LIME, local interpretability model explanations, SHAP, shapely additive values, which you might heard, and even for the other models like graph networks, there are similar techniques that you can use for a smaller technique like a saliency map for understanding these models. So these are easily used to understand one single prediction that you want to understand, saying, okay, as I used before, the example of going for a hike. Okay, you see how is the weather. So you can use such techniques to understand one single prediction that is given by the model. But if you want to understand the whole picture of the model, then you have to go for a global technique where you have techniques like SAGE, which is the extension of Shapley additive values adapted for global explainability, or like partial dependency plots that you can also use for understanding the global model decision-making process. So there are different models that you can use to understand the scope and in regards to the scope. So there are let's move on to the algorithm that is being used for explainability. We have two different types. One is being the backpropagation-based models. And this, when you're talking about backpropagation, this is only limited to a certain set of models, like the deep neural nets, where you use techniques like layer-wise relevance propagation to understand propagating the weights from the results through the layers to understand, okay, which layer has contributed more to this result. And there are techniques like perturbation-based techniques, where you make small changes to the input values and then thereby help you understand the decision that is being made by the model. This is the case in Lime and other models, other techniques that are available out there. And moving on to the compatibility, as I already mentioned, not all models, not all explainability techniques are suitable for all the algorithm types that we have, or the model types to be precise. And some techniques like Lime and Shap are model agnostic, that you can apply for all the models that are available. And techniques like layer-wise relevance propagation or class activation maps and so on and so forth can be applied mostly to a specific certain set of models like the deep neural nets. And this is quite a restriction that we have with these techniques. And also with the explainability stages, as we already mentioned about these two different terms that we had, explainability is mostly applied to post hoc methods. In terms of post hoc, we are applying these techniques once the model has been trained. So most of the explainability models that we discussed fall under this category of post hoc. And for anti hoc, the model is considered to be inherently independent or interpretable, so that we can understand the model itself by not applying much post-processing techniques on it. So if you ask me, are you able to explain every single model that we have right now? It's a huge question mark. Mostly not, because we have some of the limitations to these explainability techniques. One being the computation resources that we require for explaining these models, which comes with the challenge of these large weather models have hundreds of features, and these dimensions of these features are huge, so that some of these explainability techniques are not adaptable. And techniques like partial dependency plots have an assumption that the features are independent, but in weather forecasting, it's not the easy case to consider that the features that you use for prediction are independent. So this dependency of the features, which you use for the model training, makes it harder for the models to explain them. And the other factor of complex temporal interactions. So the techniques that I currently mentioned help only to understand some features that are relevant for the prediction. Say, for example, the temperature or the humidity. But this does not help us solve the bigger problem for human understanding, where we do not know, okay, is it due to any atmospheric teleconnections, or is it due to some jet stream dynamics that we have in the atmosphere that is causing this problem? So this still remains an open challenge. And another big challenge is the quantitative evaluation of these explainability techniques. So there's no fixed measure like model accuracy, where you say, okay, the explanation is good to this percentage, or you don't have any standards. So this is still an open challenge that we have in this field, and I think more research is being done on this front. And as I just complete talking about explainability, I would like to go back to the adversary attacks on increasing the trust on the AI models itself. So the AI models can be made robust, but we need to also make sure that these models are prevented from external attacks. So there are three major types of these adversarial attacks that we can encounter in life, and that's basically data poisoning, is like poisoning the data, as the name suggests, while training the model, or evasion attacks is poisoning the inference data. So after the model is trained, the user or the attackers try to attack the model with affected data. And the third one being, which is less of a concern, or is one of the least concerns, is privacy-related attacks, is by reverse engineering the model to extract personal information of people, which is the less of a case. But data poisoning and evasion attacks have been also tested out in a research where the researchers found out just by changing 0.1% data of the inference data, they can evade or manipulate the model to predict extreme events, or prevent them from predicting these extreme events, which could be a really big challenge that we have. So we look into also the countermeasures, how we can protect this is by maintaining data integrity. So to say, yeah, we protect the data for training and also for inference. And that's done by protecting your data layer in several layers. So this is what ECMWF also does by protecting the data with several layers of protection and providing only necessary access to the people that require it. And another thing is detecting and preventing it with adversarial training of the model, or by monitoring for such events, or by testing it with people by red teaming with attackers to test that the model cannot be attacked. Yeah, so there's always a trade-off of opening the model or making it transparent and saving the model to be preventive from adversarial attacks. So this will be also a topic that will be discussed after the break, where we will go through the ethical principles or the guidelines on these techniques, how we can do it. So before that, I think we can move on to a break to 10:45.
Yep. Yeah, thank you. That was now a session looking at what we have done in the white papers we will share. So there's more details in the white papers if you're interested in any of the topics covered. I'm sorry for that. But now we take first a break, and then we look at the guidance we want to give in future, and also the next steps after the project. Thank you.
Oh, yeah, we do. Yeah.
Yeah, welcome back. Now we'll come to the second block of today's workshop. Now, at first, we'll have a look into the practical guidelines. So, as a part of this work, not only did we write these 3 white papers on technical topics and ethical topics, but we also devised a set of practical guidelines, which were, of course, informed by the results of the white papers, intended for developers that address or serve to enable developers to address ethical challenges, not only in the realms of robustness and explainability, but more broadly when it comes to transparency, when it comes to documentation, and so on. Yeah, they were drafted to promote and facilitate the use of responsible AI, and focusing on usability. So on the bottom right corner, you can see the Fraunhofer EAS Trustworthiness AI Assessment Catalog. That's a 150-page catalog on all of the different risks in AI systems more generally. And what we wanted to take from this is something more usable, something which can be broken down into a few pages, which might then in the end not be a full trustworthiness assessment, but something that developers can use on a day-to-day basis. Yeah, I want to start with a short exercise. So we have these are the 6 trustworthiness dimensions from the Fraunhofer assessment catalog. So in general, the catalog serves to assess AI systems generally, assess the processes used to develop said AI systems, and how it does that is by these 6 trustworthiness dimensions. They're of course also quite influenced by the dimensions that the higher level expert group gave, which Stefan showed on his slides. And we have these 6 trustworthiness dimensions: human agency and oversight, fairness, privacy, security, reliability, and transparency. So the first one, human oversight. The question is, how are you using the AI system? Is there a human in the loop at all times, or is it fully automated? Which of course brings very different risks with it. Then is the AI application free of discrimination? Does it protect personal and maybe business sensitive data? Is it protected against attacks, accidents, and errors? Does it provide correct results? And also, and in this logic, robustness would fall under reliability. Does it provide robust results? And is the decision-making process of the model comprehensible? So transparency in this case not only entails explainability, so methods to make the model more understandable on a technical level, but also aspects like auditability, documentation, and so on. And what I want to do now is think quickly, or invite you quickly to think about 2 use cases in the framework of these 6 trustworthiness dimensions. So there you can find a QR code link, and you can join the quiz. So we have the use case of prediction for renewable energy supply. We have a short-range weather forecasting system with AI components. And the purpose of this AI system that we're looking at is to anticipate how much power will enter the power grid in the near future. And this, of course, can have an influence on the energy market. And based on these 6 dimensions that you can see on the bottom right, I will invite you to basically do a risk analysis of this use case in these 6 dimensions. So which risk dimensions seem particularly impactful to you? We have a second use case where we'll be doing it as well. I assume everything is working from a technical side. Yeah. Now we can also see the first results. So in this case, we have focused on safety and security and reliability until now. So the biggest focus on reliability and safety and security. And then there's also the question, what risks would you associate to this use case, which is an open-ended question, just to get some input. So now you should be able to access the second question as well. With market manipulation, that's a very good point, yeah. So the influence that it has pricing of the energy market. Of course, there could also be risks associated to fairness. For example, if the model works less well in some regions than in others, and that drives energy prices. Security and reliability. There are risks, but it's not risks to human life. So we would definitely have a high risk or high protection needs, as the assessment catalog calls it, in these dimensions, or medium to high, but it's not high, very high, as in the case where there might be, for example, human lives at stakes. And then we have the same example with a different use case, namely flood forecasting systems based on precipitation forecasts. So in this case, we have an AI system that uses these forecasts and is generating as an output warnings to human operators based on short and medium range forecasting, also with AI components. And optionally, we can also think about what would be different if there was no human operator, but flood warnings would be sent out automatically. So that's a thought experiment that shows the importance of this dimension, human and autonomy and control, because of course the risks are suddenly very different. And here we have reliability again, safety and security. We heard it in the last talk, adversarial attacks that are being published in papers that may be able to conceal extreme events, for example, by manipulating only very little sensor data. So that's a point that falls exactly in this category. And then we also have the question, what do you think are particular ethical risks? And I think in general, what we're looking at here and what we can see from the results of the poll is that a lot more, once again, focus on human autonomy and control. And then we also have to focus on security and reliability again. And in this case, from a protection needs analysis standpoint, I think we would say that this is a high-risk use case in these areas of reliability and security, because there is human lives at stake if warnings are missed, for example. So this is just to get a bit of a feeling for how this protection needs analysis works, because that's the basis for our practical guidelines. Here you can see on this slide the approach of the Fraunhofer AI assessment catalog. So this is, as you can see, very involved. We have risk dimensions, so these 6 dimensions that are listed before. Then you do a protection needs analysis in these risk dimensions, which tells you how important is it that there are measures taken in these dimensions, that these risks are mitigated. This is split up in risk areas even. And then on the other hand, you try to split this up until you get to a point where you can really measure it in metrics. So you set smaller and smaller goals, and at some point you can break this down to a goal. We want value X in this metric. And on the other hand, you can then argue based on these very small bits, statements that in the end your whole system is trustworthy by aggregating. So we have in robustness, we have this metric, and we are looking at a value that's good enough. And we have explainability is part of the system. And if you sum up all of these single statements, then what you'll end up with is a statement on the trustworthiness of the AI system as a whole. What we are, of course, not trying to do here is to just replicate this AI assessment catalog, because, as I said, it has 150 pages, and it is very, very high level, basically. So it's meant to be able to be applied to all different kinds of use cases. And what we wanted here is something more specific. So we also didn't want only an application to one singular use case, but something that can be used over the domain of weather and climate forecasting. And for that, the dimensions that we identified as the most relevant ones are transparency, fairness, reliability, and safety and security. Now, one could argue, well, human autonomy and control is also quite relevant, but that is mostly the case for these downstream systems. And what we focused on here is really the weather forecasting systems themselves. Similarly, one could imagine downstream systems where this data protection plays a role. For example, if we're thinking about chatbots or any kind of personalized weather forecasting applications. But what we're focused on here is in this protection needs analysis that we performed these 4 dimensions: fairness, transparency, reliability, and safety and security. And in these dimensions, we tried to give recommendations for developers. How did we structure this? Generally, they are organized by a naming convention and categorized into either general requirements or AI-specific requirements. What this means is that general requirements, there is of course a lot of requirements for AI systems that would hold the same for numerical models. And for example, when it comes to security of infrastructure, that's not a problem that's unique to AI, but we still have to think about it when we are doing AI models. And that's what this came from a feedback round of developers, actually, this categorization into general and AI specific, because I think for many people it's quite interesting to learn what is new now with AI. And then we also assigned each requirement a priority level, in the sense of, yeah, this is something that you have to think of when you're developing an AI system, because it's very basic and a necessity from the perspective of trustworthy AI or ethical AI. And on the other hand, there are things that might be more technically involved when we think about complex explainability methods that are maybe still in research states. And that's of course not something that you can tell people, okay, you must incorporate this now. But that's something that would rather lie on the could priority level in this course. Here are also two examples from the realm of data. So data sources must be reviewed for trustworthiness, considering documentation provided by weather stations, available metadata, information and alterations on whether alterations have been made to the data set. And this would be a general requirement because, of course, for inference data would hold up the same for numerical models. On the other hand, we have this coverage requirement. So it should be verified and documented that the data sufficiently cover the intended application domain, so that the data set that the model is being trained on has enough geographic diversity and covers the regions that it's supposed to operate on in the end. From this naming convention, you can see RE as the dimension, the trustworthiness dimension, so reliability in this case, and then the D is the lifecycle stage. So similarly to the second white paper where we looked at robustness along the AI lifecycle, here again we are using such a simplified AI lifecycle to structure these guidelines. So we have data, then once again model training, and the model itself, and then we have deployment and operation as the last lifecycle stage. And along this lifecycle, we present metrics and mitigations. On this slide, you can see the topics that we covered in the lifecycle stage of data. So this might be representativeness of data in the topic of fairness. It might be data and infrastructure protection and safety and security. And for all of these different topics, we thought about requirements similar to the ones that you just saw, that really at least bring the developer to keep this topic in mind. Yeah, these are given for all of these 4 dimensions. They're intended to be practical in some cases, also linking to, for example, outside information like templates that can be used for set documentation requirements. And they focus on the ethical concerns given to this broad use case of weather forecasting. So it's not, we wouldn't say we applied the assessment catalog to one use case, but it's rather a new set of requirements for a broader use case. Then in the second lifecycle stage of development, model development, this includes evaluation and testing and all of these aspects that I talked about briefly in robustness, for example, over-smoothing in metrics or trade-off between different metrics in which you're testing your model, and fairness, of course, subgroup performance assessment. So is the model performing the same on different groups? Then we have all these questions of uncertainty quantification and reliability and robustness. So all of these ethical topics that we also identified as part of the white paper series, we of course also included here. And earlier I also introduced it, an example for trustworthiness issues that can arise during the operation of an AI system would be data drift, for example. And that's something that's mentioned in these guidelines then, of course. And we also try to give more practical hints. For example, what is the minimum that needs to be documented when we're changing the version of an AI model? And so we have this really broad overview of trustworthy AI in these guidelines, in these 4 dimensions, but also addressing practical questions, for example, of documentation. Of course, it can't be it's not enough for every use case, basically, because you might still have to go into more detail because it's still quite a broad topic, weather and climate forecasting. But it's something that one can lay on the table next to one when working, and have in mind what are the typical issues on an ethical level that can arise. Accompanying these practical guidelines is a short principle paper where these 4 dimensions that we deem particularly relevant for trustworthy AI and weather and climate forecasting are described in a very brief way. So introducing what are the main challenges, why is this ethically relevant, and why should you think about it, basically. And the purpose of this is to hand it down to downstream providers to raise awareness of questions of ethical AI there, and also to get people interested in using the more detailed guidelines themselves in the end. Yeah, that concludes the part on the guidelines. Yes, I will.
Yes, thanks, Sebastian. So you see that with the guidelines, we were really based on some bigger studies and really developing some guidelines, because, as you mentioned, it's a lot of material, and we want to get kind of a map for developers where they have to look at and what should be their horizon of awareness regarding these ethical issues. So the legacy of the project as we have now is we have definitely raised awareness ethical issues with destination hours, but also with ECMWF activities. And with this workshop also, we're trying really also to go out and share what we have worked on it. For example, these guidelines, which we just described, we also shared with some other contracts working on it, getting feedback. But this has, of course, been only at the start. So there has to be also a little bit of proof of how these can be used in day-to-day work. We have started to create some material as described, and which we will share with you, especially the guidelines presented. You will find there's still a draft, and I think it's version 04, 05 now. We're really looking for some more feedback and some wider discussions about them, because they have been now very much developed on this theoretical map, but we really want to see also how in practice they work. And as we mentioned earlier, things also need to be adapted to your use case. Some risks are higher than others, and some of the values need to be under more scrutiny than others. So you have to adapt these guidelines to that. But at least I want to give, as I said, a bit of a map, a bit of an outline of where the developer has to look. So when we talk about the framework, so we think we have some material, but we know it's a much bigger topic. We also know it has to be really embedded. It should not be a checklist which somebody looks at 5 minutes before a release and check that these things have been done. It has to be in from the different stages, as Sebastian described, and it has to be really part of the business as usual. As in cybersecurity, GDPR, all these things, it has to become something everybody's aware about and reacting on. But it should also not become too constraining, because we're really keen also, of course, to make progress and we get to the users. But as I said also before the break, it's a bit building this trust and showing the adoption of ethical values also means, of course, they can quicker adapt to our new systems. As I said, there's a lot here where developers and service providers need to judge which areas are really the important ones, but at least they have a map, as Sebastian shown, where they have to look at, and then they can make an informed decision to say, yes, this is an area we need to be more careful, this is an area we need to be exploring further, we need to perhaps have extra checks. And then, of course, it's in everybody's interest to build trust, because you want to have users trust your product, your service, your data source, because that is what makes them come back or even pay and invest into you. So what we have learned is, I mean, when we started off with the guidance and framework, we really became very quickly clear there's a lot, and you might have seen also from the guidelines, there's a lot of heavy armory behind it, and that can be quite threatening to developers or service providers and make them hesitant. So we really wanted to see that these guidance in actually empowering the developers to have like this map, knowing which areas to look at and not feeling like there are blind spots which will catch them out later. So, but it's very important, as we also said with the lifetime study, to have really this trust element from the design, from the start in your decision-making process, so that you can really build on that while you go along. This cannot be something attached at the end. Again, very similar to cybersecurity, very similar to GDPR. So it should be always seen in the context of the other good practices we have learned over the last decades in software developing and providing services. There's a lot we found in value in AI literacy. So it's very important to, I know from ECMWF, we've spent a lot of effort, internal training, but also training with users. It's so important to really share what AI is different about, what are the challenges. So this AI literacy, what it means to use AI, is very important, so that we all have clarity when it comes to decision making of if we use this service or this data set, and know what we are doing. So again, developers have here to decide with the appropriate level of that, because we can also do the opposite. We can flood users and then they will not be able to judge anymore. So we need to find the right level of which information to share, but it definitely there has to be information sharing, because it's a new area and we all need to build this new trust and this new confidence to using these kind of new technologies. So as I said at the very beginning, the challenge a little bit for us is a downstream aspect. For example, Sebastian, the two use cases he showed, this is not something which you have not to think about when you design a global model or something. These are downstream application, and we need to be, as provider of upstream models, services, we need to think about it that we are also supporting these more downstream application, because they might start, if they reach a higher risk level, that they have obligations about transparency, openness, reporting where data comes from, all these kind of things. If we are open and if we are transparent, is helping them downstream also to do their obligations on this reporting of that. And the AI literacy will, of course, help you a lot, because it will mean that downstream users will have smooth support and also knowledge to do the right kind of adoption, because it's not just about putting data sources and models together, it's also to know what is the right combination in the situation. So a bit looking ahead. So definitely the work has shown us that we really want to do better on providing guidance and reassurances, and all the work we have done here, and I hope you find also the documents when we share them with you very interesting, and also something for you to further explore. Destination Earth and ECMWF will, of course, definitely work on this one. We'll continue out. We are also talking about making this more part of our training parts and things. So it will be integrated as such, and will be worked on. But very interesting, one lessons I have not mentioned, but it's really about, we need to also work as a community. And as a community, because it's very similar when I mentioned the Anima framework at the beginning, we can save ourselves a lot of energy if we have a harmonized approach and work together. And it's the same with ethics. Even so, and you saw already, there's different definition of the values. We have 5, we have 7, we have 10 values. So there are different lists and they will change, but it's more as a community, we harmonize our approach, how we define ethical values and how we talk about the risk levels. As easier it will be as we as community exchanging constantly data sources, models, it will be much easier for us also to talk about it and accessing if we try to take a new software, a new application, a new service, we all talk about the same way about how the risk is. And that's why I'm quite happy that HumanNet, and I will actually let our colleague Marek from the German Weather Service speak in a second. But that HumanNet has an AI program, and as part of this AI program, they've also now created a working group, and that exactly is the purpose of that is, of course, we will feeding into, and I'm very happy that we can from the beginning feed in our experience and our work. But you might have also seen already there are more angles to that, and I'm happy that as a community we will work together to have a common approach. And if Marek is already online.
Yes.
Brilliant. Thank you, Marek. So I hand over to you to give a bit of an overview of how the work will be continuing in the HumanNet context.
Great. Thank you, Stefan, for the very kind introduction. And yeah, I believe as a person from Met Service, working also with these issues, it's very important that we harmonize and exchange on this field. And there comes in one of the HumanNet activities in the EAI program with a working group that we formed last year on ethics. And I would like to give a brief overview about this working group and then the special work that we do towards ethics and guidelines. So let me see, I can click. Okay, so just one word, the EAI is the HumanNet activity on artificial intelligence and machine learning for weather and climate and environmental applications. And it came from the same motivation as ECMWF, started to look into this machine learning model that at some point there was the AI, and it was like a bit overwhelming, and then directors of the Met Services decided to tackle this topic together, and they formed this program that I'm the coordinator of, together with Roland Potters, to manage the program. And the objective of this program is really to enhance the collaboration between the European national meteorological and hydrological service, but also with the external partners. And they include, of course, ECMWF and HumanSat. And I hope you're all familiar with HumanNet. That's the framework of European Met Services. And if you want to find out more, check out their website, HumanNet EU. And on the next slide, exactly, we have an overview of who's participating in this program. So there are about 20 national Met Services, 19 from the EU, and lately we were also joined by our Canadian colleagues. So there's a big international collaboration, and of course also with HumanSat and ECMWF. So we have a lot of partners, and of course there are also the questions of ethics and regulations and documentations come up, and that's why last year in November we established a dedicated working group that exchanges on the topics of ethics and regulations. So and it was similar to presented here. So to develop a shared understanding, and we can definitely learn from the material that was developed in the Destination Earth program. So we want to develop a shared understanding of the regulatory and ethical challenges about AI and ML, especially for weather and climate services. So really focused on our main activity field. And by this, we want to identify common guidelines and best practices so that we know all the good material that is around. And I'm definitely looking forward into sharing the guidelines that you developed here. And of course, we exchange on the information on national European guidelines and identify relevant groups for us of external stakeholders, policymakers, and so on. But one really practical part, and that's, I think, continues maybe the work that was presented in the last presentation here on practical guidelines, is the idea to establish a collaborative framework for addressing regulatory and ethical questions. And actually, we started this work already a bit, but it's really like in its infancy. It's just starting, and I hope the slide comes up exactly. So our idea is to develop a really practical guidelines, a guideline to guide the development, but also the deployment of AI-based services in our meteorological agencies. And it's supposed to be practical and actionable guidelines. So really something hands-on that developers and others can follow step by step. And I believe in the end it will become somewhat a common denominator of the national regulations. And as Stefan said, it will help us to harmonize the approaches and the understanding of what is ethical and what we have to look on. And from practical side, we think of this really as a collection of comprehensive checklists. So one example you can see on the right, where we jumped on the topic of IPR and data protection. And there our vision is to have like a step-by-step guideline. For example, one task would be to evaluate that you have the right IPR to use all foreseen training data for building the AI model. And then we give like a blueprint and checklist, and also always examples. That, for example, for the data, you get a checklist to write down which data you're using, which license it's published under, who's the owner, and maybe also a comment, and then you can go through all this, and then in the end, this will help you to have a structured document that then documents your AI process or model system, and having such kind of a structured risk assessment, or this kind of structured document will then also support risk assessment, as it includes all the important information. And as I said, this is a collaborative effort. So we would very warmly welcome your contribution from your experience. So for example, if anybody has already written an AI documentation of a system to introduce it, then please join the activities and identify your guiding questions, because then we can take up them in this harmonized framework. Or do you have any national guidelines and requirements that you're working on? We can make them more visible, because I believe together we can establish best practices, a harmonized best practice in meteorological services. Exactly. And to join our work and discussions, I invite you to register for the AI ethics working group in the lower left. There's the link for the registration form. And the second link is goes to GitHub, where we start to work on the document that I just showed you on the right. And you're also very warmly to join us there. And if you want to get involved, then please feel free to contact us. Contact information should be on the next slide. You can reach out via email or by registering to the working group, and then we can work together on forming a harmonized framework document that helps us all to document and explain the processes and build trust and all the features that have been mentioned before. Thank you very much.
Yeah, thank you, Marek. I think it was very good, and it's really nice to see also. This is now the way, if you now get interested and want to know more, see what's happened next, this is a forum where you can expect we will continue the discussion for the community. And it was, I think, for me personally already quite interesting to join these discussions, because of course something we did not do in this project now was we did not, is because we were looking very much at what came from the European Commission and what is at ECMWF. We did not have national guidelines, and that is of course something which then day to day will hit and will be applicable to all these different national weather services or service providers. And this is something, of course, we need to see how we align that, because there might be slight differences between these regulations and these guidances. But as more we can work as community and find our voice, I think you heard it now from us both, that the harmonization will be very much helpful, and in future we want to exchange between these services. Thank you, Marek.
If I may add, I think one also important aspect here is to point out that once we show that we have a good documentation, then this might also become part of the regulatory requirements. So I think we can also help to form the regulatory framework that we are working in by giving a good example.
Yeah, that's a very good point. Yes, because this would not be the first time that actually something which was started by the community then also gets adapted into some regular framework because it makes sense and it is already used and has been applied on the ground. So that's a very good point. Thank you. Yes, I mean, we have now given a bit of time, the rest of them, to have a bit of a question and answer. We please use the Q&A, but we also have the chance, if you have some bigger contribution or question, we can actually also open the microphone if you want to raise your hand and have any points you would like to discuss. I think you will have seen from our presentation, this is not a closed chapter, the opposite. There's a lot more to come and lots more to develop and to exchange about. So we see that really as a kind of a starting ground for the discussions. Any more? But I have to quickly have a look at the Q&A if there was anything more come in.
So there was a question from Short van der Klauw
Yeah.
regarding, so he said he liked the setup of the guidelines and would like to have a copy afterwards. There was also another question regarding the white papers, how those could be accessed. All the material will be circulated to the participants after the event, and there will be links to the documents. But Short also asked, what are our experiences with the use and claim on time of such an effort, especially to check the boxes or fill it in from a compliance perspective? And I think Sebastian is probably the best to answer that question. But one point was that during the discussions, that was an important point because based on this Fraunhofer AI assessment catalog, which is really comprehensive, it consists of, I think, around 150 pages. This obviously takes a lot of time, which is warranted for really important critical applications. But for smaller prototypes, etc., as Sebastian will tell us, we thought the discussion resulted in that developers wanted something that could be quickly used in their day-to-day use.
Yeah, we really try to restrict ourselves here. So to stay at about 5 pages for the guidelines themselves and 10 pages for the whole document. That's of course very different, but also the purpose, as George just said, is very different from the original Fraunhofer catalog, where the purpose was to really assess an AI system in all its dimensions, which is something that of course can take weeks for even one AI system. We've done this multiple times, assessments of AI, external AI systems, for example. And in this case, of course, it's very different, and we're not looking to assess a ready-made AI system, but we're looking to how can we incorporate ethical concerns in the development process. So yeah, as for the time, it's very difficult, but it's quite a short document, and we try to be very concise.
Yeah. And speaking as a manager who wants to have these developments developed, I would say they should be as short as possible. But I already made reference to cybersecurity and to GDPR. Yes, I think I remember with all of these coming up that people talk about the time and effort these will take. But yes, they still take time, but they have now become so ingrained, hopefully, in our workflows. And this should be the same with ethics. And that's why I think this approach also which Sebastian presented, to keep it short, because we know also developers will not read a 150-page document. So it has to be short. 5 pages we thought as a reasonable compromise to give something meaningful, but still have time. But it's a big question, and I agree. And as I said also, and this is also the signals you will see from the Commission, like with the November Digital Omnibus, there's a big focus of not blocking or not being a stone in the way of progress. So we need to find a middle ground, and that's why it's so important also to have the discussion. And yet, I see the question on the documents. Yes, we want to share it, and we are actually very, very keen to get feedback, and hopefully, it will also help to get started some discussion, as we mentioned in the HumanNet activity. So there will be, we have your email address because you registered for this seminar, so it will be shared with you, and then we'll very much look forward to some feedback. Yeah.
There was also another question regarding the ethical frameworks by Lucy Morn. Are these frameworks based off any existing frameworks, guides, legislation, or are they being designed from scratch for Destination Earth?
Yeah, I think that Sebastian can mention it because that was one of the reasons why we wanted to start with something bigger theoretical. But yeah, Sebastian, you can.
Yeah. I think the term framework implies that it contains everything, which it doesn't right now. It's not the purpose of the document. So of course there were a lot of existing documents that went into this guidelines, but I wouldn't call them a framework because it doesn't have the intention to cover all trustworthiness aspects for all possible use cases in this rather broad domain of weather forecasting. For example, if we started doing that, then we would also have to go into the data protection GDPR and so on. And that's a whole new topic. And autonomy, auditability, there are so many adjacent topics that don't lie maybe at the heart of it, but are still important. So I wouldn't call it a framework, but as I mentioned, there's the work that it's based on is the AI assessment catalog, which is a larger work, and we've also taken other existing documentation, for example, in the references, and looked for the white papers, for example, through standardization on these topics.
Yeah.
So,
and definitely the field will also develop and change. So this is a kind of snapshot and starting point. But I think we benefited a lot having this based on an existing bigger study and framework and however you call it. It's because it was really helpful to have that instead of starting something from scratch. Anything more, Jody, on the?
Yes, there are multiple questions by an anonymous attendee. It was previously mentioned that it's still a challenge to explain the atmosphere drivers that produce a weather forecast that is AI-based. Why? I think it's something useful if it can be explained in the AI-based forecast. That is true. Of course, it would be extremely useful to to have fully interpretable models, but the way that these models are architected, their architecture, is just not fully interpretable. They are very complex models, and they learn from the data, but they don't incorporate physical laws implicitly. So that is why we cannot, fully attribute those drivers to certain forecast results.
Yes, and again, even all these model developings will change and adapt over the time. So it's a bit hard. So there will be also progression. So something to be watched in future. But yeah, good point.
And another by Miles Ballestar. How do ablation studies on individual Sentinel mission contributions address the ethical requirements of data representativeness evaluation and physical plausibility validation in your multimodal fusion framework? I think this goes very deep into the workings of the systems. So I think from yeah, in my point of view, this might be a bit too detailed for this session, but I think probably someone from the team would be happy to address this question in the aftermath.
Yeah, I think it goes a bit deeper than the ethics side, but yes, of course. To be fair, every center who's doing a large global weather forecasting or any environmental forecasting, they will make studies. What are the values of different data sets? It's actually even politically important because if you want to justify the investment in new instruments, new satellites, it's a lot of money, and you want to show kind of what will be the value or what the values come from these different instruments. So, but these kind of scenarios, what if scenarios about data sources in or out, this is exactly where the digital twin concept of DestinE comes in. But again, this is not the topic of this presentation, and we'll talk about. But it's a very important topic to have. But I don't think it's at the moment something we want to can discuss this today.
Yeah, so I think the only thing that we can say here is that indeed these, for example, the AIFS, they are evaluated against physical plausibility. So, for example, there's analysis of the energy spectra, etc. But I think for more detail, we would need to refer to some documentation.
Yep. Any more queries or any more questions? Is there any hand raised or anything? No. No, because otherwise, I mean, we have, of course, as I said, this is an ongoing work and will be continued in the future. But we are quite interesting. You will have seen we focus on specific topics. You saw them presented before the coffee break. If there's anything you see actually which needs to be looked after now in future and which you would have perhaps felt missing today, which you would have expected to be covered, that would be quite interesting. As I said, when we go forward, where we should put efforts and where we should have a look at it. Then also, what are the most important factors for you as a developer user to have trust in AI forecast? What you find challenges? So because we're still building this trust as a community and user base. So please let us know also if there's anything specific you feel like you would like to be covered or feel interested about should be addressed. And then also, what is your difference between now the AI and the physics-based modeling? How you see the difference? How does it impact how you think about the values regarding ethics about that? So, if you have anything comments to that, please put it in the Q&A, or as I said, we can give you speaker right if you raise your hands. We're very happy to give you also the microphone. There's
also one more question by Lucy Morn. I tried to answer it by typing a text, but I think there's still maybe one part of the question that's remaining. She asked, do the open competitive challenges truly help to build trust with the public, or does it just create a confirmation bias where people who already trust the system use it? Do you collect any data to measure this? So I answered that yes, the people that participate in the challenges will be usually familiar with meteorology or machine learning. So the competitions do not directly increase trust with the wider public, but they engage people outside the weather services themselves and are a starting point for innovation and adoption of these new techniques, and they improve AI literacy. But Stefan, maybe you know a bit more about the evaluation of these competitions. If you have any insights, who the participants are, how these competitions are adopted, and so on.
Yeah, no, I think competitions are actually it's a very good way for us, because in the past, when we talked about weather forecasting, climate forecasting, you had a very limited list of organizations who were doing it. And for example, through the World Meteorological Organization or UMetNet or something, you can easily talk to whoever is operating in that field. Now we have a lot of, in the private sector, hyperscalers, universities, but even small SMEs coming up and building new system and new ideas. And we need to somehow find a way to talk to them. And these competitions are really, really good for that. So, for example, DestinE had supported the AI Weather Quest on the sub-seasonal to seasonal forecasting range for AI models. That has been a really great success on bringing this community together. And it's a really across the different domains of who has engaged with that. So it's a really good way to come together. But we fully agree, and it's one of the lessons which we actually kind of assumed also from the beginning, that of course there will be some who will be fortunate enough that they can engage with such a competition, and that might be then a group which bias us from the experience to, for example, we see some geographical areas around the globe which have not engaged, so they might not be covered well on this. We have seen that some industries have not been there. So it's really important, even our traditional weather forecasting centers, that they're also getting involved. So it's really important to engage, and that we spend a lot of effort trying to get these gaps filled and get this thing. But I fully agree, there's a danger. It's a new field. What we learn, that it's biased by the ones who get involved first, and it's always a question of resources, people you can spend time to follow something. But I think ECMW is already through training and through DestinE also through its outreach try to reach these. But there is a danger, and I think we need to keep an eye on it. So yeah. Was there any more comment or? If there's not, I mean, then I think then we can move to the last slide. And that is, as I said, we want to continue with you to be in contact. We will be in touch with you after this meeting in a few days' time. We will send this information, and we're really looking forward to your feedback. In the meantime, you can already fill out the survey to this webinar. There's a QR link, and also I'm sure it will be also shared later in emails. Stay in touch with all the different developments. DestinE is actually very good in outreach training, information sharing. So please make use of that. So you will find these kind of developings also covered and described further in there. Also, when we talked about what in a technical side is happening, that is all very well documented and covered on the DestinE web pages. ECMWF, we have a lot of blogs. You should, if you're interested in this topic, you should definitely follow the AFS blog we have at ECMWF, where you can find the latest developments on the AI modeling side from the ECMWF side. So very interesting articles over there over time. Please follow that. So, and otherwise, yes, we're hoping to hear from you after and we hope you find it interesting and helpful what we presented today, and yeah, keeping in touch.
We do have another question.
Oh, is there another question in?
Yeah. Georgie, do you wanna?
Jody, that's another question I heard.
Oh, how will the ethical guidelines help with governance of extreme weather? That's a very broad question. So our hope is that these ethical guidelines will help in creating data-driven models that incorporate these ethical values and thereby decrease bias, increase their robustness, and in turn, that hopefully will help our systems to better deal with extreme weather and to better prepare the public to deal with the extreme weather events.
Yeah. And I would add to that, yes, it's totally right. But the messaging about extreme events, about probabilities, how it will strike, area, all these kind of things. We need the public to trust, to buy into these messages. We need industry to react fast. So all these need to have trust in what they get told in these kind of events. And as I said, there's a danger with AI that we might have an information flood in future, that there's different sources of information. So users, and that includes decision makers on government side, industry, the public in general, they need to trust, because it's not a matter of us just throwing more and more data out. It's really to have an impact, and that it changes people's life to the better, hopefully, and they can do the right decision for adaptation. And that means they need to trust. So that's why I said these ethics is not another hurdle at the side for your work. It's really important to get the buy-in from your users to actually also follow and work with it and make this whatever we are forecasting and modeling its success, and that it creates the right kind of impact. Yeah, I think that was a nice general question to finish off. Yes, if there's nothing else, then I would say again, thank you for the speakers. I hope that it was very helpful for you all, and hope to hear from you all in future with feedback or in the HumanNet working group over the next years. Thank you very much.
Thank you very much. Good night.